Okay, I'll continue from here. We find that the current rating is normally in the range of about 5 amperes to 15 amperes. But here in this case, since we need the amperage as high as about 400 amperes in some cases, we need a step down transformer where the voltage is brought down and the current rating is increased. Now, here you can see the electrodes, for example, and these are coated electrodes. You can see that no, this is the darker one, the darker part what you see here, that is the base metal, and the white part which is surrounding this dark part will be the flux. Now once the welding power source converts AC to DC, and the required voltage and amperage are achieved, it is going to be transferred using cables. Okay, so we have welding cables here. You can see these are the two welding cables which are shown, and you can also see that there is the earth clamp. Okay, so which means earthing is always negative, that is the cathode. So this terminal which is coming will be the negative terminal, and the one which is connected to the electrode, it is mentioned here as a covered electrode. It is covered or coated electrode. You need an electrode holder also in order to hold the electrode. So that will be the anode part. So this is another figure which is representing the same. Here you can see the two workpieces. This is one part and this is the other part which need to be joined, and here this is the welding which needs to be done. So we can see that there is again the welding machine here which rectifies AC to DC, and you also have a step down transformer which reduces the voltage to about 70 volts and increases the amperage. And you can clearly see here that the workpiece is connected to the negative part here, while the electrode will be connected to the positive terminal, that is the anode. Now how exactly this arc welding takes place? No, we will go through the continuous explanation, the full explanation now. Now before we start the welding process, the two plates or the two parts which need to be joined have to be prepared. We call that as preparation of the joint or the surfaces. Now you can see that the surfaces are not perfectly straight here. A kind of a wedge is created. This is to ensure that whatever void is there here, blanks of space, that will be filled by the molten electrode. Okay, so this is a electrode which has coating as well as the base metal. So this base metal will melt and it will occupy the space here in this part. So once we make the connections, proper connections, we know that the current rating is very high, and generally the heat produced or the heat loss, you may have studied it earlier, is I square R. Okay, so we have the heat produced proportional to the square of the current, and R is the resistance or the resistivity. Now generally what happens is the two pieces are kept side by side, and the electrode is made to touch the one of the surfaces. Okay, in between the pieces it is made to touch, and then the moment you touch, what happens is a complete circuit is made, that is electricity starts flowing. So if you keep it in that position, no arc will be produced. So what you need to do is you need to touch the electrode to the workpiece and retract it back by about 1 to 2 mm. Now when you are retracting it back again, because we are breaking a circuit, there is a spark which jumps from the electrode to the workpiece, and when a spark jumps, because of the spark and because of the I square R losses localized here, there is a large amount of heat which is generated. It is as high as about 5 to 6,000 degrees centigrade. So there is localized melting which takes place. So it melts here, the electrode also melts, and this electrode is coated with the flux. Now generally if aluminum oxide or borax is used, what happens is it forms a gaseous shield. Because the temperature is very high, In all the places there will be some amount of humidity, that is moisture content. So there are chances that oxides are formed, and if oxides are formed, then that will weaken the welded joint. So in order to prevent oxidation, flux is used. So the primary function of a flux is to prevent oxidation. So what happens is, we have this gaseous shield. Okay, so you can see this curved part everywhere here. There is a gaseous shield and there is an arc. And you may ask, when we have retracted the electrode back by 1 to 2 mm, circuit is broken, then how is it that the arc will continue to remain? Now again, what happens is, whenever we break a circuit and maintain a distance of about 1 to 2 mm, if you remember, when we had applied about 10,000 volts in case of a spark plug, the spark jumped between the two electrodes. But in this case, what happens is, once a spark is initiated, there is localized formation of plasma, and plasma is a good conductor of electricity. So through plasma, this spark will get retained, and from one end to another end, from the front end to the rear end, you will have to slowly take. That is, you can see in the previous. So here we can see that the electrode will be moved from one end to another end after the spark is produced. Now, this electrode is normally not held vertical. You can see that the electrode is at some angle. It is not straight like this. Okay, so there is a small angle at which it is to be maintained. This angle varies between around 45 degrees to 60 degrees. Once both the base metals, we call these two parts, that is this part and this part, as the base metals. Once the two base metals along with the electrode melt, they form a pool here, and after you allow it to solidify, it looks something like this. This is the final welded joint. Okay, so the two metals have formed a homogeneous union. You'll also see that, in spite of taking all kinds of precautions, there will be some amount of oxidation, there will be some amount of splatter, and so on. What do we mean by oxidation? There is a layer, the dark part, which is on top of this. You can see the dark part which is here. That is the splatter. That is the slag formation. We call it as slag, SLAG. And what may happen is, when you are carrying out welding, there is a lot of sparking, and the molten metal may form dots like this on the by the side of the welded joint. Now that makes everything look very ugly. So once everything cools down and the whole thing solidifies, we will have to clean the surface. Now this cleaning is done by what is known as a chipping hammer and a wire brush. Okay, so using a chipping hammer, oxides are formed, the slag is only at the top here. So once you use a chipping hammer, these oxides, the layers of oxides, come out very easily. And then using a wire brush, that is, it's like a regular brush only, but it is made up of wires, that is metallic wires. So using a wire brush, you can clean it properly. Now even after that, you can see that there will be a bulge. So sometimes, in order to form a flat surface, a straight surface here, there is a localized grinding which is done. There is a handheld portable grinder which is used in order to make it flat. So once it is done, once it is cleaned, and once it is ground, then we will have a proper welded joint. So this is all about electric arc welding. And a couple of things what you need to remember is, what is the meaning of a flux, what is the meaning of a slag, and what is the need for using a flux, and why is flux not used in TIG and MIG. When we study about that, you will come to know. This actually, complete discussion on electric arc welding is mainly direct current straight polarity, and that is sufficient. You don't have to understand about direct current reverse polarity. The arc length what has been shown here is about 1 to 2 mm, as I just mentioned. So this concludes our discussion on electric arc welding. In case you have any doubts, you can always message me, or you can call me and get your doubts clarified. Thank you very much.